Hi guys, welcome back to my channel. So let's continue where we left off from the last lesson. 3 days ago, we talked about TT. 2 days ago, we talked about PP. Yesterday, we talked about wee wee. And today, ladies and gentlemen, get ready for this. Today, we are talking about we tan square. Funny, right? Let me go a little bit in depth of what I'm talking about here. Some people are a little confused, you know. It's okay, it's okay. I'm trying to bring joy into math, okay? Today, we're talking about a secant and a tangent line. So before I introduce whatever, we have to be able to identify which line is which so I know where to use the correct formula. Okay, if the line is only touching the circle one time and one time only, it doesn't go in there, it just touches, that would be my tangent line. So therefore, line segment AD right here, I'm going to label it, it's going to be my tangent. Now, this tangent is different than the tangent we learned in trig ratio. Okay, in this case, tangent representing a line. So therefore, that if it's coming from the outside point, touches the circle one time, continues to go through it, and ends at the end, this one is a secant. Secant. I'm going to add the word line. Okay, hope that helps. Now, if you have taken trig or algebra 2, you should know we talk about secant and other things more in depth, but in this case, we're only talking about lines, not angle measurement, okay? So let's get into we tan square and let's see what on earth Ms. Zhang is talking about. In order to find me parts of it or the entire thing, when I'm dealing with one secant and one tangent, I need to look at we tan square. So let's look at the example here. It's DC multiplied by DB. So I'm going to use a highlight, a color ink. It's the same thing. The whole thing, the entire thing multiplied by the outside, external, when I'm talking about a secant. So it's DC, which is this entire thing. I'm going to use a highlighter, okay? So DC, entire thing, multiply by the external, which is DB, this one right here, multiplied by the external, is equal to the tangent line multiplied by itself. So tangent line is AD, so it's equal to AD multiplied by AD. Okay, and I call it we tan square. Let's look at example 1 to see how we can use we tan square. Now, in the diagram below, tangent PA and secant PBC is drawn to circle, okay? So it tells me that PB is equal to 4. So PB is this line segment right here is equal to 4. And BC is equal to 5. I'm looking for PA. So again, I'm going to use a highlighter. Well, in this case, it's a marker. Okay, so I'm looking for PA. X, so I have a tangent line, which is PA, and I have a secant, PBC. I know that I need to use we tan square. It means that the entire thing multiplied by the external of my secant. So the entire thing is going to be PC itself. So 4 plus the 5 is going to get me 9. Multiplied by the external, multiplied by the outside, which is equal to 4, is equal to tangent square. So tangent line is PA. I need to look for that, so I marked it as x to the second power. 4 times 9 is equal to 36, is equal to x to the second power. Taking the square roots, so x is equal to positive 6. Since we're talking about distance, our final answer cannot be negative, okay? So therefore, that length of PA is going to be equal to 6. Not bad, right? Pretty straightforward. Let's look at my second example. So my second example saying that, okay, so I have another circle. PA is the tangent, secant PBC. Okay, pretty similar. PB is equal to 3. So PB, let me use a color ink. So PB, so this outside is equal to 3. BC is equal to 15. What is length of PA? Okay, so we're still looking for the same thing, which is the tangent line. Okay, so PA, which is this one right here, I'm going to mark it as X. So I know that whenever I have a tangent line and a secant in the same problem, I need to use tan square. So W, the whole thing, which is PC. So that means 15 plus the 3 multiplied by the external PB, which is multiplied by 3, is equal to tangent to the second power, PA x to the second power. 15 plus 3 is equal to 18. 18 times 3 equal to x to the second power. 18 times 3 is going to get me 54, equal to x to the second power. So therefore that x is equal to radical 54, or if you put it in the calculator, you're going to get 7.348 approximately. Okay, so therefore that PA, since they didn't really tell me how to round it or which digit to round it to, I'm going to say that PA, it's approximately equal to 7.3. If the question is not being specific, then you just have to round whichever you want, okay? But if the question stated that you have to leave it in simplest radical form, then you have to follow the instruction. So this is the end of today's video. If you like my method, right, remember to write it down. So I have tangent, TT. 2 chords, right, PP. If I have 2 secants, if I have one of each, tangent and a secant, I have tan square. Hope this video helps, okay? I'll see you guys in the next video. Goodbye.